Hello guys, welcome to today's tutorial. We want to solve y prime prime plus 6y plus 10y equal to 0. Whoa. What am I saying? The right hand side is not equal to 0. So this is kind of like different from the ones we've been solving previously in the past where the right hand side is 0. So this is a non-homogeneous linear constant coefficient. Okay, second order differential equation, ordinary differential equation. Now the best method to use to solve this kind of problem is called undetermined coefficients. Okay, so solution. Now I'll tell you why I said undetermined coefficients. Now when you're given a problem like this, y prime prime plus 6y prime plus 10y equal to 50x. Now observe the right hand side carefully. The right hand side will teach you the methods that you should use. Now when the right hand side is in let me say a polynomial form, or when the right hand side, okay, possible right hand side is polynomial, or maybe when the right hand side is a constant, or maybe when it is trigonometric, or maybe when it is exponential, or probably when it is hyperbolic. Okay, so for our polynomials, you know, the likes of x, we have x squared and so on and so forth. For constants, we just have numbers basically. Then for trigonometric, we have our sine and cos basically. I will not include tan for some reasons. So for exponential, we have exponential plus or minus ax. Okay, then for hyperbolic, we have sine x, cos x. Okay, so when your right hand side is any of these particular forms, any of these elementary forms listed here, then you can apply the method of what? Undetermined coefficients. So apply method of undetermined coefficients, so UDC. So we are going to apply the method of what? Undetermined coefficients in what? Solving these problems. So for this particular tutorial, let me assume that you know the general forms for representing each of these particular cases, but let me just run through it quickly, okay, just as a refresher. So just to refresh some things that are necessary for solving this kind of problem. When you want to solve a problem that is non-homogeneous in the sense that the right hand is not 0, then your general solution will be divided into two: yc plus yp. Your yp is called your particular integral, and your yc is called your complementary function. Okay, now your complementary function can be got or can be obtained by solving this particular equation when the right hand side is 0. So in the complementary function, we are just assuming that the equation is homogeneous. So we'll set the right hand equal to 0, we'll solve for the complementary function, and we'll get it and keep it somewhere. So the particular integral can be gotten by making some assumptions depending on the method you're using. Now when you're using the method of undetermined coefficients, I just want to refresh our knowledge of undetermined coefficients. So we have functions, and we now have general forms. Okay, functions and general forms. Now when you're using the method of undetermined coefficients, when you see a constant on the right hand side, okay, the general form of the constant will still be a constant. Now when you see a polynomial like this, for instance ax, or let me see, when you see a polynomial in degree 1, for instance, you see something like kx. Okay, the general form is going to be what? Ax plus b. Okay, so this is the general form of a polynomial in degree 1. So a polynomial in degree 1 is generally a straight line. So you have to use the straight line representation of any polynomial in degree 1. Now when you see a polynomial in degree n, okay, when you see a polynomial in degree n, kx square for instance, let me start with kx square, then I'll find the general form of representing a polynomial of degree 2, which is basically like a quadratic equation. So it will be ax square plus bx plus c. Okay, so this is going to be the particular integral representation of any right hand side that I see in this particular format. So what if I see a polynomial of degree n, kx raised to the power of n? So I'll generate a polynomial. Let me call this one a n, then x raised to the power of n plus b n minus 1 x raised to the, or a n minus 1 x raised to the power of n minus 1 plus dot dot dot. Okay, I'll keep generating this polynomial till I get to a1x then plus a naught. Okay, so you just generate a polynomial of degree n. So still flow with me. Now when you see an exponential form, okay, when you see an exponential form like something like exponential kx, okay, exponential kx, where k is the constant, then the general representation of your exponential form is going to be let me say there's a constant here, or there is no constant, r exponential kx. Your general representation of an exponential will be an a exponential kx. Okay, this k remains as it is, but you're just assuming an undetermined coefficient a in this particular case. So r will be known based on what you are giving on the right hand side. So whenever you're giving a sinusoidal form, okay, you're giving either sine and at or cos at. Whenever you're giving a sinusoidal form, sine at or cos at, so you're going to use the general form of representing a sinusoidal function or a trigonometric form, which is actually a cos at plus b sine at. Okay, so this is the general form. When you're giving a sine alone or a cos alone, this is the general form, a cos at plus b sine at, that you're going to use to represent it. So when you're giving a hyperbolic form, okay, let me say a sine at or a cos at, you can also use a general form of representing hyperbolics, which in this case will be a cos at plus b sine at. Okay, or when you're giving a hyperbolic, you can convert it into their equivalent exponentials. Okay, you express it in exponential form. Okay, in exponential form. Now I might not write the exponential way of representing hyperbolics now, but in another video just after this one I'll show you how to do that. Is that okay? I'll show you how to do that. So let me stop here for now. Let's quickly solve this particular problem. Okay, when you're given this problem, you want to use the method of undetermined coefficients. So first things first, the first step is to obtain the form for yp. So yp in this particular case, the yp in this particular case will be derived based on the form of the right hand side. In the right hand side, I'm seeing a 50x there, so I'll have to use the general form of representing a polynomial in degree 1. So the form of my yp is going to be ax plus b in this case. Okay, so let me call it equation 1. Now it is important to first of all state what your yp looks like. Is that okay? State what your yp looks like. So the next thing is to obtain yc. So obtain yc. So remember that y is equal to yp plus yc. Now these values a and b are called undetermined coefficients, and we are going to determine them in the course of the solving of this problem. So to obtain yc, you need to what? Assume that y prime prime plus 6y prime plus 10y is equal to 0. So assume that is equal to 0. So the characteristic equation or the auxiliary equation, let me assume I use a variable r is r squared plus 6r plus 10 equal to 0. So if I solve this quadratic equation, I'll get r is equal to minus 6. Using quadratic formula, plus or minus, I have 6 squared minus 4ac, which is 4 times 1 times 10, then all over 2a, which is 2 times 1, and that is 2. So my r is going to be minus 6 plus or minus, if you evaluate this, you're going to get j2, okay, over 2. And if you evaluate this, you get negative 3 plus or minus j, or plus or minus 1j. So since the roots of the quadratic or of the characteristic equation is complex, so what you're going to do in this case, of course, your yc is going to be what? Okay, this is the real part, and the imaginary part has a coefficient of 1. Therefore, it will be an exponential minus 3x, open brackets. You have your c1 cos 1x, then plus c2 sine 1x. Okay, so this is your complementary solution, or your complementary function obtained from the homogeneous case of the given differential equation. Now that you have obtained your complementary function, you are now going to recall your assumption for yp. Yp was ax plus b. Is that okay? Now you're going to compare the particular solution, your particular form, the form of your particular integral. Okay, I want to use the right languages. So compare, let me call this equation 2 and this is equation 1. Now you're going to compare the form of your particular integral with the complementary function. And what are you comparing? You're checking to see if any term in the particular integral repeated itself in the complementary function. Okay, since there is no repetition in our case, we can go ahead with this particular integral. But if there is a repetition, you might need to modify this particular equation 1 a bit before you can work with it. If you don't modify it when there is a repetition, you might actually find yourself in trouble. You might not get the right answer. So in another example, I'll explain what I mean by this. But now we are safe. No term in the particular form, the particular integral form, is repeating in the complementary function. So the next assumption is that the particular integral, the yp, must satisfy the differential equation given to me, which is y prime prime plus 6y plus 10y equal to 10x. So our yp must satisfy y prime prime plus 6y prime plus what? 10y equal to 50x. So the implication is that yp prime prime plus 6yp prime plus 10yp must also be equal to 50x. Is that okay? So this means that we need to obtain yp prime and yp prime prime. So yp is we have ax plus b. Okay, so our yp prime is going to be, if you differentiate, you get a. Then finally our yp prime prime is going to be 0. Okay, now that we've gotten yp prime and yp prime prime, we are going to slot them into these positions. Okay, so in slotting them, I'll have 0 plus 6 yp is 6 times a, and plus 10 6yp prime, that's 10 times a, then plus 10yp, which is 10, and ax plus b is equal to 50x. So you have 6a plus 10ax plus 10b is equal to 50x. So 10ax plus 6a plus 10b is equal to 50x. So you're going to compare coefficients. So terms in x. So you can see that the coefficient of x on the left hand side is 10a, and the coefficient of x on the right hand side is 50. So for 10a equal to 50, what is the value of our a? Our a is equal to 5. Is that okay? So when you compare constants, when you compare the constant term, on the left hand side the constant is 6a plus 10b. On the right hand side the constant is as good as 0. So you have your b to be, from this equation, b is going to be negative 6a over 10. Now when you slot in the value of a, you have negative 6 into 5 over 10, which is negative 3. So you've gotten the value of b. So now that we've gotten the value of a and b, which initially we labeled as the undetermined coefficients, our yp is now complete as according to the form of the yp, which is ax plus b. So we have our yp to be ax, which is our remind me, it's going to be 5x and minus 3. Now that you've gotten yp as 5x minus 3, so you have to recall that y is equal to yc plus yp, and we already know what our yc is. This is our yc, we got yc over here, then our yp is gotten over here. So our y is now going to be, our yc is exponential negative 3x into c1 cos x plus c2 sin x, then plus yp, which is plus 5x minus 3. Okay, so this is your solution for this particular non-homogeneous differential equation given to us above here. Okay, so that is the solution. Okay, so we are going to solve another example, and as we solve another example, and I'll keep explaining more about undetermined coefficients. So this is for this one. Please like, share, subscribe, hit the notification bell to stay updated, and if there is any question at all, you can drop it on the comment section and I'll attend to them. So see you on the next video where we solve some other more complex examples in undetermined coefficients. Bye.